7.1 Trig and right triangles. Well, as we start off, we're going to talk about two special types of right triangles that you studied back in geometry. One type was the 45-45-90 right triangle, where the two legs were the same and the hypotenuse was always the square root of 2 times the leg. So the ratio was 1 to 1 to the square root of 2. And the other special type right triangle we looked at was a 30-60-90. And that one had a ratio of 1 to square root of 3 to 2. So across from the 30, the smallest leg was 1, and the hypotenuse is always the biggest side, which was 2, and the long one was the square root of 3. Those ratios could come in handy when sometimes you can use trig, but other times we can use those ratios to solve some problems. So, since we mentioned trig, let's look at the trig ratios that you learned back in geometry. From an angle, from one of the acute angles of a right triangle, not the right angle, you have a leg adjacent to that angle, and you have a leg opposite that angle, and you have a hypotenuse. And if we remember, the sine of an angle is the ratio of the opposite leg over the hypotenuse. And the cosine is the adjacent leg over the hypotenuse, that ratio. And the tangent of an angle is the opposite leg over the adjacent leg. And then we had three reciprocal functions. Cotangent was the reciprocal of tangent, so it is the adjacent leg over the opposite leg. Secant is the reciprocal of cosine, so it is hypotenuse over adjacent. And then cosecant is the reciprocal of sine, and so it's the hypotenuse over the opposite leg. So, hopefully you remember different ways to remember those. One of the common ways that we taught was SOHCAHTOA, which was sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then you just have to remember your reciprocal functions, and one trick that helped me remember the reciprocal functions is S goes with C. So sine goes with cosecant, and cosine goes with sine. C and S, and not sine and cosine together. So just a little trick to help you try to remember those. Well, let's do number 1 here that says, first let's label all the sides of this triangle, and then we're going to do some ratios. So if across from the 30 is just, the shortest leg is 4, well, the hypotenuse in a 30-60-90, the hypotenuse is always double what the short leg is. So that'd be 4 times 2, or 8. And the long leg, which is across from the 60, is always square root of 3 times the short leg. So that'd be 4 times the square root of 3. And this triangle is a 45-45-90 right triangle. So if one leg is 2, the other leg is 2, and the hypotenuse is 2 times the square root of 2. So now that we've got all the sides labeled, let's look at some ratios. And maybe you'll notice some trends here. So sine of 30, so sine, we're looking at the 30-degree angle. Sine is the ratio of the opposite leg over the hypotenuse. So 4 over 8, which reduces to 1/2. Cosine of 30 is adjacent over hypotenuse, so that would be 4 square root of 3 over hypotenuse was 8, and that reduces to 4 goes into 8, just a square root of 3 in the numerator and 2 in the denominator. And tangent of 45, well, it doesn't matter, they're both 45, but tangent is opposite over adjacent. Tangent will be 2 divided by 2. Tangent of 45-degree angle will always be 1. And cosecant of 60, let's look at that one. Cosecant of 60, well, here's the 60. Cosecant is the reciprocal of sine. Sine was opposite over hypotenuse, so we want hypotenuse over opposite. So it's 8 divided by 4 square root of 3. And that reduces to 2 over the square root of 3, which is the unrationalized version. But to rationalize, we have to multiply by the square root of 3 over the square root of 3, so that becomes 2 square root of 3 divided by 3, because the square root of 3 times the square root of 3 is just 3. And secant of 45. Well, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so we want hypotenuse over adjacent. So that is 2 square root of 2 divided by 2, which will just reduce to square root of 2. And the last one, cotangent of 60. Here's the 60. Cotangent is adjacent leg over opposite leg. So 4 divided by 4 square root of 3, which reduces to 1 over the square root of 3. And when you rationalize, you multiply by the square root of 3 over the square root of 3, and you get square root of 3 divided by 3. Moving on to number 2 that somehow I did not catch is labeled as number 3, misnumbered. What a surprise. I do that quite regularly. Sorry about that. On number 2, we have 2 sides, and then we want to identify all 6 trig functions, so trig ratios. But to do the ratios, I need all 3 sides. So step 1, we need to find the missing side. So we're going to use Pythagorean Theorem. And we know the 2 legs, so to get Pythagorean Theorem, you'd say leg squared plus leg squared equals hypotenuse squared. So the hypotenuse is going to be the square root of our 2 legs squared. So 5 squared plus 8 squared inside the square root. It's supposed to be connected there. So that is the square root of 25 plus 64, which is 89, which is not a perfect square, and I do not think can be simplified any, so we leave it as the square root of 89. So now we have all 3 sides, so now we can write our ratios. So on our first ratio, we have sine of p. So we have to look at which angle we're talking about. P is here, so sine is opposite, so you have to find the opposite leg, which is 8. And we divide by the hypotenuse, square root of 89. Which is a correct answer, but not rationalized. So to rationalize, we're going to multiply by the square root of 89 over the square root of 89. And you get 8 times the square root of 89 divided by 89. Cosine of p. Cosine of p is the adjacent leg over the hypotenuse, so that's going to be 5 over the square root of 89. And when you rationalize, that becomes 5 times the square root of 89 divided by 89. And then tangent of p is the opposite leg over the adjacent leg, so that'd be 8 over 5, and that's as far as we can go on that one. Can't be reduced. And the other 3 are reciprocals, so if we know tangent is 8 over 5, we know cotangent would be 5 over 8. And reciprocal of secant, secant's a reciprocal of cosine, so if we take, I'm going to use the unrationalized version here. If we take the reciprocal, that's going to be the square root of 89 divided by 5. And same thing on this one. This will be now, if we take the reciprocal, cosecant is going to be the square root of 89 divided by 8. And there are 6 trig functions. So for this one that was labeled as number 4, that is technically number 3, we were given cotangent is 7 over 20. And we want to find sine. So let's draw a little triangle first so we know it helps us to be able to visualize this. So, whoops, there's my right triangle. And here, I'm going to call this angle right here theta. So cotangent is adjacent leg over opposite leg. So adjacent leg is 7, opposite leg is 20. So we need to find the hypotenuse again. So we have to take Pythagorean Theorem, which is going to be a squared plus b squared equals c squared, or square root of the 2 legs squared. So 7 squared plus 20 squared, which is 20 squared is 400, 7 squared is 49. So let's write that in there. Just square root of 449, which I do not think is a perfect square, so we're just going to leave it like that. And now we want sine. Well, sine of that same angle theta is opposite over hypotenuse. So sine, and you always have to put theta, so you have to put the angle when you're talking about your trig functions. So sine of the angle is equal to the opposite leg, which is 20, divided by the square root of 449. And we can't leave it unrationalized, so if we rationalize that, we're going to multiply it by the square root of 449 over the square root of 449, which gives you 20 times the square root of 449 divided by 449, and that's not even, and not a multiple of 10, so we can't, or 5, so we can't reduce that any, and that would be our correct answer. But then it asks for one more trait. It says, okay, now tell us what theta is. Well, we know that sine of theta is that value there. To get theta, we either have to take, we could use this cotangent or this tangent, but we have to undo a trig function. And to undo a trig function, I'm going to go back to the original one. If I ever made a mistake, it's easier to always use the original. So it's cotangent of theta was 7 over 20. Well, to undo a trig function, we have to do the inverse trig function, which the inverse trig function is called little -1 exponent. So if we take an inverse trig of cotangent of theta, then we have to do the inverse trig on the right side too, of 7 over 20. So I'm bringing in an inverse trig to cancel out the trig, and have to bring an inverse trig here too. One other trait that I need to remind you about is you might see this in the future. The inverse trig is also called an arc trig. So this is also called arc cotangent. It's kind of antiquated, not really anybody uses that term anymore, but it does show up in some future math classes, so I wanted to make sure that you've seen like arc sine and inverse sine are the same thing, and arc cosine and inverse cosine are the same thing. So inverse cotangent, we'll cancel that out. So my theta is equal to whatever the inverse cotangent of 7 over 20 is, and I can't do that without a calculator. So we go to a calculator, we get make sure we have to, since we're talking about degrees, theta was in degrees, so I need to switch this to degrees. So if I click it, it's automatically on degrees, or you have to go to home and you have to do some settings, but that was the fastest and easiest. Like from home, you'd have to go to settings and then document settings. The problem here is if you do change it here, but then you use, escape, use the scratch pad, it doesn't always change it. So good way to do it is just to click on it with, move the cursor up there and click to make sure you're in degrees. And then we have to go to trig, and I want inverse tangent. No, we were doing cotangent, wasn't it? I better double check. Inverse cotangent, not tangent. So let me backspace that out of there. Trig, inverse cotangent of my angle, or my sides, my ratio, which was 7 divided by 20. So inverse cotangent of 7 over 20 is 70.7 degrees. And they didn't say what to round to on this one, so we'll round in there to whole degree, which is 71 degrees. So theta is approximately 71 degrees. Now, for number 5, it says if cosecant is 8 over 17, or 17 over 8, sorry, what is tangent going to be? So here's another one that if we draw a triangle and label one of the two acute angles as theta, cosecant is the ratio of the reciprocal of sine. Sine is opposite over hypotenuse, so this is hypotenuse over opposite. And this time, to do Pythagorean theorem, we would have to take hypotenuse squared minus leg squared. So 17 squared minus 8 squared. And that, I can't do that in my head, but you can do that with the calculator. You'll get to 15. Now, a little trick, the reason I did that so quickly without a calculator is there are some Pythagorean triples that if you know those triples, they show up as right triangles all the time, like 3, 4, 5. And any multiple like 6, 8, 10, doubled of 3, 4, 5. Or 30, 40, 50. Well, 3, 4, 5 is a Pythagorean triple. 5, 12, 13 is a Pythagorean triple. 7, 24, 25. And 8, 15, 17. If you know those right there, you've just saved yourself time on, especially standardized tests like PSAT and SAT. They use those a lot. So when I saw that I had a hypotenuse of 17 and one of the legs was 8, I knew the other leg was 15. Without having to do Pythagorean theorem, you can do it faster. So you don't need to know those, but it is a useful skill to have your Pythagorean triples because they're going to pop up a lot and it saves you time. So, like I said, though, we can still do Pythagorean theorem if you don't have those memorized. So let's see. We now know 3 sides, 8, 15, and 17, and tangent of the theta is the opposite leg, which is 8. So tangent of theta is equal to 8, opposite leg over the adjacent leg, so 8 over 15. And we are done with the front side. So for number 6, it says solve the right triangle given PQ is 24 and QR is 18, and we're going to round the sides to 1 decimal plate and the angles to nearest tenth. So on this one, PQ is 24 and QR is 18, and we want to solve the triangle. That means we want all 3 sides and all 3 angles. Well, we can go ahead and do Pythagorean theorem, or you could notice this is 6 times 4. This is 6 times 3. So that's a 3, 4, 5 right triangle. So this would be 6 times 5. So that is 30. And if you didn't want to do that, you could just do Pythagorean theorem and do 24 squared plus 18 squared and then take the square root. Or like we said, if you notice, those Pythagorean triples show up a lot and you can save yourself some time. So we now have all 3 sides. Now we need all 3 angles. We have one angle is 90. So let's see, from angle P, we can use any of the three sides. I always like to go back to the original ones they gave us, because if I made it, what if I messed up on this? I don't want to risk getting every answer wrong, so one good way is use the sides they gave us. So from angle P, we have the opposite leg and the adjacent leg. So tangent of P, tangent of theta, or P, is equal to the opposite leg, which is 18, divided by the adjacent leg, which is 24. So to get rid of tangent, or to undo tangent, we have to do the inverse tangent. The inverse tangent of both sides would cancel it out here, so it's the inverse tangent of 18 over 24. And for that, we need a calculator to make sure we're in degrees. So calculator, I've already got tangent, so trig, button, inverse tangent, and then we just type 18 divided by 24. And that would be 36.9 degrees, or did it say to, what did it say to round to? It said angles to nearest degree. So theta, so P, that with theta was angle P was 37 degrees. So P is 37 degrees. Now, we could do inverse tangent and use this angle, or use cotangent, either one, but if you already have one angle is 37 and one angle is 90, well, we know the degrees of a triangle are 180. So if one angle is 90, the other two have to add up to 90. So 90 minus 37 would give us angle R, which is 90 minus 37, which is 53. Yes. So we now have everything we need. We were supposed to find all three angles. So R was 53 degrees. P was 37 degrees. We know Q was 90 already. There's our three angles and our three sides. PQ is 24. QR is 18. And the third side, PR was 30. So PR equals 30. So now at least I'm all written down. So, okay. So now everything's circled, but I didn't want to rewrite it all, so it's all there. So for number 7, we're given that side G is 42, and we're given that angle F is 63 degrees. And we want to find side F. So we're looking for side F. So on this one, I look at what we're given. We have, from this angle, we have the opposite leg we're looking for, and we know the hypotenuse. And opposite and hypotenuse is sine. So sine of the angle, so sine of 63, equals the opposite leg divided by the hypotenuse. And now, to solve for F, you would just multiply both sides by 42. So F is equal to 42 times the sine of 63. And this is the ones you got to watch out when you're typing in the calculator. A lot of people do sine of 63 times 42, and if you're not paying attention, the calculator opens the parentheses here, and they don't pay attention that it didn't close it. So you want to make sure that you close the parentheses before you multiply by 42. So that's why I like to put the number in front. So I'm going to type in 42 times sine of 63, and then I don't have to worry about any issues on that. 43 times sine of 62. Make sure I type that right. No, 42 times sine of 63. I got my numbers backwards, sorry. 42 times sine of 63. And that is 37.4. And what did it say? Did it say to round to? Round to the nearest tenth. So F is 37.4 units. Now, let's move on to number 8. Number 8 says, solve the right triangle. So that means we're going to want all three sides and all three angles. Using the information given, round answers to 2 decimal places if necessary. So we have a right triangle. The angle C is the right angle. So I'm going to draw a right triangle. Angle C is the right angle. And we have an alpha, or we have an A, little a. Well, little a would be across from angle A. So, and then we have a beta, which is the angle, that's an angle B. So this is angle B, beta is 22, and little a is 7. And we want to find side C, which is across from angle C, and side B, which is across from angle beta or angle B. And then we also want to find alpha, which is angle A. So that's an alpha, because they use, just for some reason, sometimes the math problems will use Greek letters for the angles. So let's see, what do we know? We have, well, I know if this is 22 and this is 90, then I can get alpha. That one I can subtract from 90. So angle alpha, or the angle A, is going to be 90 minus 22, which is 68 degrees. So now we have all three angles. Alpha is 68, beta is 22 degrees, and C is 90 degrees. So we've got all three angles. Now I need all three sides. Well, right now the only side A is 7. So let's look at how to get B. Well, from this angle that was given, B is the opposite, and we know the adjacent. So opposite and adjacent would be tangent. So tangent of the angle, 22, tangent of 22 equals B divided by opposite over adjacent, B divided by 7. So to solve for B, I'm just going to multiply both sides by 7. So B is going to be 7 times tangent of 22, which is, let's use our calculator, 7 times, and you don't have to put the times when it knows to multiply when it's right next to it, but I like to be explicit on that. 7 times tangent of 22, and that is 2.8. I don't remember what it said around to. 2 decimal places, so 2.8. 2 would round up, so 2.83. So this B is 2.83. So the only thing left now is side C. Now you could do Pythagorean Theorem. My one tip is if you do Pythagorean Theorem, don't use this rounded answer. Use the long calculator answer. You can write down a rounded answer, but if you're doing any calculations, don't round until the very last, until you're writing it down. So if you're going to use Pythagorean Theorem, make sure you use the long extended decimal, use that whole decimal number there. But you don't have to use Pythagorean Theorem. You could use another trig function. So, whoops. So we know A, and we're looking for C. So we have the adjacent, and we're looking for the hypotenuse. So adjacent over hypotenuse is cosine. So cosine of 22 is equal to adjacent, which is 7, divided by the hypotenuse. Well, this time, my C is in the denominator, so I'm going to multiply both sides by C, and that gets it out the denominator. And then to get C by itself, you would have to divide by cosine of 22. So C is equal to, if we divide both sides by cosine of 22, we get 7 divided by cosine of 22, and that would be 7 divided by, oh, it helps if I click down here, 7 divided by cosine of 20, cosine of 22. 7 divided by cosine of 22 is 7.55. So C is 7.55. So now we have A, we have B, and now we have C. And so we have all three angles and all three sides, and we are through with number 8. So number 9 says two sides of a right triangle, ABC, C is the right angle, are given. Find the trig function, find the indicated trig function of the given angle. So we're told that we have a triangle ABC, and C is the right angle again. So one of these is A and one of them is B. Doesn't matter which is which on how you draw it, because it's where you label things that matter. So side A is 7. So side A is the side across from angle A. So side A is over here. That's 7. And side B is across from angle B. That's 10. So we have one leg is 7, one leg is 10. Those are not Pythagorean triples, so we're going to have to do Pythagorean Theorem. And 10 squared is 100, 7 squared is 49. So square root of 100 plus 49. So square root of 149 is our hypotenuse. I did 10 squared plus 7 squared equals this side squared, so to solve for this one, I had to take the square root. So now that we have that value, we are told to find what is the sine of A. Well, sine is opposite over hypotenuse. So sine of A is equal to opposite leg, which is 7, over the hypotenuse, which is the square root of 149. That answer is correct, but not rationalized, so we will multiply by the square root of 149 over the square root of 149, and we get sine of A is equal to 7 times the square root of 149 divided by 149. And there is our answer to number 9. And now let's talk about one more terminology that some people have learned before but you don't remember. When you're talking about angle of elevation, an angle of elevation is always measured from the horizontal upward. It's like the way your eyes are looking. You have to look upward to see if you're elevating. An angle of depression is measured from the horizontal downward. Well, angle of elevation is inside that triangle. Angle of depression, if we're looking at this triangle with the lighthouse, it's outside the triangle. But a nice little tidbit is, if you think back to geometry, when you have two lines that are parallel, alternate interior angles are congruent. It is the equivalent, it's congruent to the angle of elevation. So the angle of elevation and angle of depression are always going to be basically the same angle. Just one's horizontal downward that's outside the triangle, but it's equivalent to what's inside the triangle. And one is inside the triangle looking upward. So, knowing that, let's look at number 10. While visiting Walla Walla Park, Joe approximated the angle of elevation to the top of the mountain to be 25 degrees. So that's from the horizontal upward was 25 degrees. After walking closer, he determined that the angle of elevation had increased by 12. So once he walked forward, here this angle of elevation is 25 plus 12, so 37 degrees. And approximately how far forward did he walk? So we want this distance here is what we're looking for. That's our question mark. If the mound that he was observing was 367 feet tall, so this is 367 feet. So what I have is one triangle was when he started, had an angle of elevation of 25, and this was the height was 367 for the mountain, and we need to find that length there. And we have a second triangle, and drawn a different color, so I'll go to red again. So the second triangle has an angle of elevation of 37 degrees. This is still 367 feet tall. And now this is a different variable because this is only from here to the height of the mound. So if we use our trig ratios, I have from this angle I have opposite and adjacent. So in blue I'm going to use tangent and write down what we have. So tangent of 25 is equal to opposite 367 over adjacent. And I could have used cotangent and then put the variable in the numerator, which also works, but we can multiply both sides by x and get that out of the bottom. So x is going to be equal to, you would divide by tangent to get x all alone. So 367 divided by tangent, but it's never just tangent, it's tangent of an angle, so tangent of 25. And let's go ahead and calculate that while we're here. So 367 divided by tangent of 25, 367 divided by tangent of 25, tangent of, come on, 367 divided by, it didn't get tangent, there, tangent of 25, third time's the charm, is, we're going to round to the nearest foot, so 787 feet. So he was 787 feet away originally. So from all that distance was 787 feet. Well, now we also have this great red triangle that we drew. So let's see, that would be tangent of 37 is equal to opposite, which is 367 still, over adjacent, which is y. So if I solve for y, we're going to multiply by y and divide by tangent. So 367 divided by tangent of 37. So 367 divided by tangent of 37 is 487 feet. So now y is 487 feet. So that tells me this distance right here was 487 feet. So if part of the distance is 487 feet and the total distance is 787 feet, to find out how far he walked, we're just going to find this distance, we're just going to subtract those. So 787 minus 487 is he walked 300 feet. And I really shouldn't, instead of rounding to the nearest whole number, I think we're okay, but you really should have used the decimal numbers before. I shouldn't have rounded to the final answer. So I could double check that. Let's take, we want that long decimal, which is really long, minus the other long decimal, And that way I don't get round off error, but if you know, it still rounds to 300 exactly, so we're okay on that one. So 300 feet. And that right there is enough information to help you get through this entire assignment on the trig and right triangle problems. Good luck to you.